Hey, this is Grandma, and today I'm playing with Spinner Toy in MakeCode Arcade. We are going to really have some fun. Okay, our first fun is going to be, let's see, if you look up high a little bit, here are all the links that I pasted that have to do with today's code. And on my blog, which is at WeCodeMakeCode.com, I have written a description of how to use the spinner toy and other information that is relevant, including the mixer schedule for the week. It looks like I could have taken all morning if that's what I had really wanted to do. Okay, also on GitHub, our programs are there, and I've given you those links. And I also have documentation on GitHub, although it's more thorough on the blog. Okay, there. Now, you've watched me demo this is Spinner Toy, and it has lots of features. And you saw me demo it. I'm going to run through it right quick for people who might not have seen it. Okay, I don't know why I'm having this trouble. Okay, just a second. Okay, so it has lots of features. First, you can restart it. It generates several, 5 in fact, random polygons, random speed of rotation, random colors, random size. Ooh, that's a nice one. I like that. And since the speed is random, it's very unusual for 2 polygons to have exactly the same speed. Okay, I'll quit being so fascinated. If you want to take some of the polygons away, you use this. If you want to add some more, you use that up, and it gets a little busy after a while. If you want to color them differently, you use that, and it does random colors. And if you want to make them all go the same speed, now they have different rotation directions, but they have the same speed. If you want to make them all go the same direction, hit the left arrow again, and if you want to turn them the other way, cool, do that. Okay, you can change the speed using the slider, and notice I turn the slider on by hitting A, and then these directions go, let's get some more. Okay. Then the up and down arrows control the speed. And actually what it's controlling is the maximum random speed. So the speed is generated 0 to 4. Okay. And that's about all the features. Now, I want to show you one more program, which I've given you the link to, and I call it very creatively Polygon with Sliders. Okay, I created this as a test program for my Polygon extension, and I did it long before I had added the spinner feature to it. So what this does is it uses sliders to demonstrate different types of, I will tell you, these are regular polygons, not just any kind of polygons. Regular polygons all have the same sides and angles. So this slider is obviously changing what's called the radius, which is the center point to one of the vertices. Then this slider is the number of sides, and notice as you change the number of sides, it briefly flashes the name of the polygon. And it will, notice when we get up to 30 points, it's pretty much a circle as far as pixels when you're doing it in pixels. And let's see, we can change, let me get rid of so many slides. We'll go down back to 3. Then if we want to do the color, that's this one. And in fact, if we didn't know what kind of slider this was, we hit A and it will tell us it's for color. Okay, we'll turn that off. Now, it will cycle through the colors. And of course, I am extremely fond of, yes, I have trouble picking colors because they're all so neat. And then the next slider is that one, is really fun because that is the rotation angle. And so when you start drawing a polygon, the algorithm, it asks for where do you want the angle to start around the circle. It can be anywhere from 0 to 360. And notice that as I change directions, it rotates the opposite direction. And then I thought to myself, I would like to have a thing called a spinner. So that's why I created spinner. Okay. Now what I want to do is I want to start from scratch. And I want us to build a cool program. We're going to call this our Scratch Spinner. Now, notice we have no extensions here. What happened to Polygon and Slider and all those things? Well, we're not going to use Slider here, but we are going to use Polygon. And I could go to the link that I provided you on GitHub to download this, or I could use the shared link. But this is called Polygon Extension 2, and sometimes I call it Polygon Extension, and I've forgotten what GitHub says right now. At any rate, they're the same thing. So I'm going to select that. And when I add Polygon Extension, I have 2 new menus, Polygon and Spinner. And it added both of them because they're both packaged in the same code. Why did I do that? It's because I didn't know how to package them differently, but I would like to find out. Okay, so let's make us a little, let's make a polygon. I could use a good polygon today. Okay, start. There's my polygon. Now I could make it with different numbers of sides. I could have its radius be bigger. I could color it a different color. And I could give it a different starting angle. See? And see, that's what causes it to rotate. Okay, now we have a polygon. Okay, let's start over and just use the initial values. And now let's make a spinner. My spinner. A spinner requires a polygon as an argument. And you can do it like this. Now notice its speed is 0, so let's make it go faster. Now its speed is 3. Now when you're making a polygon, a spinner, you can either do it this way where you create the polygon first, or I'm sure you probably know, just like we do with sprites, you can put it there to create it. And then it does them both at the same time. See? Then you can create a spinner in one step. So now let's make this spinner move around. And how would we do that? Well, turns out a polygon has inside it a sprite. So we can use all these sprite things to make this polygon do things. So if I look at Polygon and get its sprite, well, gee, I don't have my polygon anymore, so I guess I better put that back. There. Okay, it moved over, so I want to use acceleration because it's really cool. And let's set it up there somewhere to maybe Let's set it to a random number. Let's do that. Okay, math. I love random numbers because they do things differently each time, sorta. Okay, so let's make it from -50 to 50. And we'll make an acceleration in the y direction to be exactly the same. Okay, let's watch and see what we got here. Okay. Oh, it's gone. Well, we know how to fix that, don't we? So I'll just get to the sprite and I will tell it to bounce. So we want this sprite and we want it to bounce now. Okay, now it bounces. Now the only thing better than one polygon is 2 polygons. So let's put a repeat loop around here. Let's just make it 2. Okay. Now they're kind of boring because they're all triangles and they're all red. So let's do a little more randomization here. We'll make the sides be 3, 2, 6. And we'll make the radius be, what do you want the radius to be? Maybe 10 to 50. I think 10 is the smallest that you can do, and 50, so we already got 50. Okay, we got 2 polygons, but they're the same color. Let's give them a random color. How about 1, 2, 14. And then of course if we wanted a whole bunch of them, there they are. How cool is that? Okay, let's go back to having just 2. Now, I would like, there's the potential for using these polygons in a game. And of course that's, in a way, what MakeCode Arcade is all about. Although as I've gone along, I've realized more and more that it can do so much more. Well, I like games, but it can do a lot more than just play games. So, let's make these polygons interact with each other. So the typical way of doing that is to use an event like when they overlap. Now I didn't change the kind of polygon because it defaults to player. In my actual program I changed the type to polygon or to spinner, and then down here I said if type of kind spinner, so because you might want to have other types in your program, and player might want to be you, not the polygon. So what do we want it to do? Well, how about they sort of bounce off each other, but we'll only use the X direction just because we're kind of lazy. So we're going to set my sprite X to other sprite X, but I'm going to make these velocities. Okay. Oh, I'm doing the wrong thing. Thank you for telling me that. Okay, so now let's do the same for Y. Now, not too surprisingly, they just stay pretty much right together. So what I want to do is actually make them go in the reverse. So I'm going to do this. Make it go negative. I'm not making much progress, am I? Okay. There. There. So now let's see what happens when they hit each other. Now these two are big. Let's see if we can get two kind of smallish ones. Oops, I should have kept those. Okay. Now let's watch what happens here. See? It's kind of like they repel each other because I reverse the velocity of one of them in the X and the Y direction. Now, one thing that happens when they get close together like this, they generate a great many events. So let's just make score be the number of events. So we're going to have a score, which is in information. We're going to set it to 0 up here. And then we're going to change it by 1. Every time we get one of these. Look at that. See, we don't want that because it's doing way more intersecting than we want it to. Now what I've learned is a really good way to take care of this problem is to use time. And someone asked the other day about how to do this on one of the MakeCode streams. So, okay, here's one way to do this. We're going to use an if statement around this whole thing, and we're going to require that the time since the prior time, I need a logic thing. I want this to be greater than, and we want to go to game, we want the game time since start. This is going to be the biggest number, and we're going to have a variable called prior time. And we're going to change it right here to be the time before, which would be that time. And now then I'm going to subtract prior time from there. And if it's, let's say half a second, if it's in a half a second, we can now do this. Now I should have initialized this up here in this on start, so we'll just do that. Now watch, this is not ticking up so much, so it's not resetting these velocities. What I'm afraid of is that if it resets these too fast and comes in here a lot, then it keeps on reversing it and pretty much doesn't do what you expect it to do. Now it's looking like these things are staying apart. They're bouncing off each other. And sometimes I've experimented with making this even 1 second, which is just to put 1,000 here. So unless they've, okay, now I did have another one. Now you can tell when these are happening. Now that seemed to happen too fast, but maybe not. So you can make this any time that you like. Now, what if we just had quite a few more of them? Okay, those are all really big. I think it would be more interesting to have some that are much smaller. So we're going to change the radius from 10 to 15. Now they should try to stay away from each other. That is what they're doing. And if we were doing this, the next thing I would add to this is I would put all these spinners in an array, and it turns out you can do that. And I would have a prior time for each one of them, so that when it ran this event, I could check to see which spinners it was and judge the time based on that spinner as to whether or not it had had an interaction. But I think this is pretty cool. They are trying to stay away from each other. Now, let's take, well, what else could we add to this? We could add something else to this, couldn't we? How would you make this into a game? That's what I always ask myself. How could I make this into a game? And I just invented spinners, so I'm not quite sure what the game should be, but I'm going to continue to think about it. Okay, let's go look at the spinner toy code to just see what are some of the more sophisticated things I did in this program. Okay, one thing I did which actually surprised me that I could do it. I created a Okay, this is where I just set up the speed slider, and I position it by giving its left coordinate, and I set it selected to false, and therefore it's being blocked by a image is put over it. I call it the cover, and then when I hit A, I unblock it. Okay. Then I can explain these later. And I created a list called the spinner list. Now, I didn't know that this was going to work because, as far as I knew, usually lists only work for numbers and strings and sprites. But I thought, why not give it a try? So, here, when I launch a random spinner, the 0 means I've forgotten what the 0. Oh, if it's 0, it's a random spinner. If it's a number, it launches one with a fixed size radius. Okay, so I create the polygon, and the difference here is that is the radius. So if it's non-zero, I put the radius here so you can make any size polygon you want. I set its Z level to 2. This keeps the spinners always on top of the slider and the blocking cover. And I set the spinners, the kind of the sprite, to spinner. That way I can, in the overlap event, I can check for spinners, which I thought was a little neater than checking for player. Now look at this, spinner list, add value, spinner to the end. Now, that's cool. And then the next thing I call up here somewhere, give spinner random movement. Oh, that's not, I do that, I use that later, I think. So now let's look at some of these. The A button, which displays the speed limit or not. So I just invert whether or not that spinner is selected. Selected is a property of a slider. Selected is a property of a slider. This is a slider because it slides. And if it is selected, then I want the cover to be at -1. So that means that black cover, goes underneath the slider. And if it's not selected, I want the cover to be 1, so it hides the slider. The slider's still there, and it still has a value. It's just not showing, and you can't change it because of the way I did I checked for that in the buttons. Now, in this program, what I did when two things of type spinner overlap, there is a variable called bFollow, and that's set by, I think it's by B. We'll look at it in a minute. Then it causes a sprite to follow another. So let's see, is that the one? Yeah, so now it threw them all up in the air, and then this will cause them to follow. Throws them up in the air, now they're going to follow. So this follow is a technique I use to create hula hoop, and which you may remember. Okay. Next, let's look at the B button. See, this is what I was just describing. If it inverts the follow. So if bFollow is on, it sets it to false, and it gives the spinner random movement. And that's what happened over here in this routine. To give the spinner random movement, what you do is, in this cool, you get to the sprite using the polygon, and notice it's using I like this, using the spinner list. And so for every spinner it does in the list, it does this, no matter how many spinners you have. It gives the sprite a random XY, a random velocity, a random acceleration, and it causes it to bounce off the wall. Okay, let's see, there they go. Okay. See, making a program that's more complex is just a matter of one thing at a time and making it work. So that was the B button. Now let's try the right button. It's very simple. The right button recolors them. So the right button just goes through the entire list that you have, and it sets the polygon color to a random number. So it just recolors them. You can recolor them all day long until you get one you like. Now, if the left button is pressed, looks complicated, but here's the idea. So when the left button's pressed, it makes them all the same speed if they were not already. So this says if not the same speed, then set them all to the same exact speed. It's the speed that's shown on the slider. So it sets them to the current maximum speed. And then it sets same speed to true. So the next time you press left, it makes them all the same direction. In fact, it makes them all clockwise, because the variable clockwise was false. So this makes them all clockwise, and of course it sets clockwise to true. Then if we do it one more time, it makes them all counterclockwise. And so that's what that little left arrow does, and that is its only job. Now, here are the downs. So down is, well, that's one down. That turns the spider. And see, when that changes, it changes everything. It changes all the speeds. Okay, and if the slider is not there, then the down button, whoops, takes away polygons. Now, why did these not spin? Well, it's because speed was set at 0. If we change speed, they will start moving randomly between 0 and 3 and 4. And as you go up, they're going to get faster. Probably. Since it's random, be really sure. Okay. So down removes, whoops, I'm sorry, when we have down removes a spinner and up arrow adds a spinner. So let's look at down first. So if the slider is selected, then you just change the slider and you do random speeds. That's a little routine I have down here. New random speeds. New random speeds would be a random number from 0 up to the value of the slider. And we will make them all go counterclockwise for the heck of it. I'm not sure why I did that. You can also choose a random direction. That's pretty cool. I like that better. New random speeds. Okay, so that's when we hit down. Well, that's removing them. Oh, the slider's not showing. Okay. Now if I hit down, we're going to get new random speeds and directions. And if the slider is not showing, the up arrow gets an additional spinner. And that is this part of the if. So test for the length of the spinner list is greater than 0, because you don't want to try this if there's no spinners there. And what I do here is I just get a spinner, which I call tip spinner, from the spinner list, and I pick randomly some spinner out of the list in order to remove it. There they go. And what I do is I just destroy the spinner. Now, if you look at the code for destroy spinner, you'll see that it actually destroys the sprite and the polygon underlying the spinner, which is a good thing. And let's see, next on the code, we've already seen that. We've seen up. What up does is add a, well, when the slider is showing, it adds 1 to the speed, and it calls for new random speeds and directions, because we just changed it. And if it's up, if it's not, the slider is not selected, it adds a spinner. Hey, I like spinners. Okay. Now, is that all the code? Is there anything we have not talked about? No, I do think that that is it. So now let's, I think I'm going to save this because I changed that clockwise. So what I do is I save it to my hard drive first, because sometimes every couple of days when I save it to GitHub, it crashes and it's not saved anywhere, and I can't get back to the screen where the code is. So I lose the code. So now I'm saving it to GitHub, and it's showing me right here that what the change was that I made, and I'm going to commit the change. Now, this is always a little bit of a mystery. Sometimes when I come back from GitHub, my code is scrambled all over the page. And I don't really like that. Okay, let's go now look at the code for, actually, I think we're going to, before we, hold let me see if we're going to look at the extensions in just a minute. So this code is pretty straightforward. In order to build this, we have 4 sliders, which you can see. One of them is vertical, that's the radius. And we have to position the sliders, and we give them a name. The slider extension, the slider gadget has a data thing called, which you can put there, and I put its name in there. So these are what you can do with slider, sorry. You create one, it has a value, you can change the value by some amount, you can set the value, it can be selected or not, and you can set that, and it has a piece of data, which is some kind of string. And then you can get to its thumb sprite, and I think the thumb sprite is on a slider. This little red thing, that is the thing that moves, that is called the thumb. And I use the same, this is pretty common terminology. And this other thing that it slides on is called the track. And sliders have been used pretty much ever since there was a user interface, a graphical user interface on computers. They were one of the earliest components that was invented because they are so incredibly handy. And of course, they're even handier if you're using a touch screen, which I happen to be, but I won't confuse you with that. Now, this is where I position the horizontal sliders, which is a little bit complicated because I want to scatter them out and have them be equidistant and blah, 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 blah. So, but it's all just arithmetic. Then after I've done that, I have an active slider. Now this is a really good trick. Since I want to select a different slider, depending on as I move B around, I have an active slider, which I set to one of these. So this one is that I set the active slider to the number of sides. And you've already figured out that the active slider is denoted in yellow, and that's all done by the extension. Then I make a polygon, and the polygon is created with the number of sides specified by the slider, the radius specified by the radius slider, the color specified by the color slider, and the angle specified by the angle slider. Cool. Now, A button, all it does, it shows the name of the slider. So it just gives its name. And the B slider moves them. So this is just rotating the selection of the sliders. And then you have to have a code to handle all the left and right buttons. And of course, this is a left or a right, and this is giving the increment that you're going to move. And you have to test which slider are you on. So you're on the slider. Don't do that. Oops. Sometimes it's just easier to do that. Don't need that. Or it might be the color slider, or if it's not either of those, then it is the angle slider, which is the fun one, because that makes it rotate. And when you get the right and left buttons, these all have to do with the right and left buttons have to do with the horizontal sliders. The up and down button is always the radius slider. So there is the radius slider up and down. Of course, you need to always check to be sure whether you're not at the minimums or maximums of a parameter like amount. And I see I hard-coded this, which was really not good programming. This should be obtained from the slider itself, and where there is a way to specify. So that code needs a little improvement. This was the code I actually developed in order to test the Polygon. So I added to this code as I added features to the Polygon. So that is that. Now I want to show you, give you a little bit of a guided tour of the actual extension. So I want to go to, let's go to the Polygon extension, because I think I've explained the slider extension on another show. Now, in extensions, all have to be written in JavaScript, or as we all well know, it's static TypeScript. But in addition, there's another language, and that's this one, a markup language, that you decorate the JavaScript with in order to tell how to build these blocks. There's a certain way you want those blocks to look, and you want certain parameters in them, blah, blah, blah. This was the hard part for me of figuring out how to build extensions, but there is very good documentation for this. So you can search for MakeCode Extensions documentation. There's also a wonderful little thing, and I'm going to show it to you, called the MakeCode Playground. And what this has, pretty much everything you might want to do in the markup code. And it has here, it lets you put it here, and then it shows you what it creates. So I went through each one of these, studying them, figuring them out, blah, blah, blah. And I pretty much was able to figure out everything I needed to know. But that's a very handy tool if you're going to write an extension. So the first thing is I put my enum at the top. I only had one of them, and that was the direction of the spinner. And then here's where the namespace Polygon is the namespace for both Polygon and Spinner. Then the place where a polygon is created is here, exports a function, and the parameters are the number of sides, the radius, the color, and the angle. And then all of this stuff has to do with how you want that to look, what the minimum values are, the maximum values, the default values, and each one of these can easily have bugs, and it doesn't tell you when the syntax is wrong, and that stuff. So it's very tedious to write this, particularly if you don't see very well like me, but I just enlarge my screen and get it as big as I can and go at it. Now I've got 3 or 4 more extensions that I'm writing, and I'm just in love with writing extensions because it makes Arcade much more powerful to do things like make spinner toys. Then the next function I have is to destroy this polygon, and this has a problem right now, and if you're really smart you could figure out what it is. Well, it is that I don't test for the existence of this thing before I destroy it. And of course it blows up if the sprite doesn't exist. So I need to put some code in. I just discovered that this morning, so I need to think about how I want to handle that. I got the same problem in the spinner. Okay, here's the class Polygon, which has a bunch of properties, and for each property, like sides, you notice that when I had Polygon, let me show you that. Like Polygon, whoops. So here, for example, see this drops down and you have several choices of things. So it's pretty fun how you can specify that in the creating the extension. So you do that by side. You have a getter and a setter for each of those properties. And if the properties have the same type, then they are all put together on a drop down. So this code explains exactly how to do that. And so it goes through all these little properties, and Angle was a little difficult because angles has a range 0 to 360, so I had to confine it to that range, and I did it in such a way that if you're just holding down the key, it will continue to rotate rather than oscillate back and forth. You can figure that out later. Okay, there's the constructor. This is just the code for drawing a polygon. That's relatively straightforward. Then I get to, oh, I'm sorry, Spinner had its own namespace. I forgot that. See, I have an export function to create the spinner just as I did before. And this morning I had a bug in the direction of the spinner because I hadn't set a default value. You probably didn't want to know that. Okay. And I also have a destroy here, and this one probably will blow up too because I'm not testing whether something exists. And I have similar properties that each have certain things specified on them to get them to look like they want to look. And then that's it. Once you have a polygon, it's pretty easy to make a spinner. Okay, I might just show you. Spinner. Spinner actually has more properties than Polygon. That's its polygon, as you know. It's like every spinner has a polygon. It has a speed. And so it has these three things are automatically generated by the markup when you specify it in a certain way. And it has a direction, which is, as you have seen, it gives you back the value of the direction. That does. And then this sets the direction, and that's where the enum comes in handy because you pick the directions from that pretty little drop-down list. Now, I hope you're ready to go home and write an extension, and I want to hear about it. And if you use these, I would like it very much if you would let me know if you find any problems. And I guess that will be the show for today. Thank you very much. There. Thank you very much. This is Grandma. Bye, bye, bye.